Hi everyone. So, continuing from where we left off in the last video, we learned about more into functions, right? So let's just scroll back up for a little bit just to do a little review. We learned about two different types of functions, right? Or two different types of relations, where we learn a little bit more about functions, but then we also learned about what we call a one-to-one relation, and also a many-to-one relation and a one-to-many relation. If you're unsure about what each of them are, feel free to go back to the last video. Then we learn about the breakdown of relations, how relations can be broken down into either functions or not functions. Right? So all functions are relations, but not all relations are functions. And then under functions, you could break down that into essentially three different classes. You could break down a function into either one-to-one relation, a many-to-one relation, or just a plain function by definition. And then relations which are not functions, they can either be one to many or many to many. Right? So that's a good thing to keep in mind there. Then we learn about another way to represent a finite function, right? Or a finite relation, which is what we call the set of ordered pairs. Right? So like this here, the set of ordered pairs gives you the pairs of inputs and their corresponding outputs. So in the first number, right, the first number of the pair, that's your input, and the second number is your output. If you're unsure what the inputs and outputs are, feel free to go back to the first video of this series, right? So we learned about the set of ordered pairs, did a few questions, and then the last thing we learned about is the range. We learned that the codomain, right? So like this here is what we call the input set or the domain, where we pull our input values from, and this output set here is called the codomain. But the in the codomain, you could have some values which are not being mapped onto by an input. So in this case, the codomain and the range is the same thing. But in this one here, all right, let's look at this relation. In the second relation here, sorry, right, what we see is that the codomain is 1, 2, 3. Those are all these values here, but the range is a set of used values, which is just 1 and 2. So that's why the range is 1 and 2 here. Right. And you feel free to go back through the other questions as well. So continuing with this here, right? We want to go into the realm now of just evaluating different relations, right? So evaluating evaluating relations. Right now, evaluating really means to get a value for a final value. But in some of these, you're not going to end up with that. But as we see the questions coming up, right? So let's say, for example, we are given that f of x is equal to x squared minus 3, right? So if we are given this, right, the question could ask us something like this here. They could tell us to determine 1, f of 1, 2, I go with parts. Part A, part B is f of negative 3, C is f of 20, D. Um, let's go with f of P, and E, f of T minus 7, and last one now, f of, um, let's go with x minus 3. Good. All right, so let's see how we go into each one of these now. So let's think about what this is asking us for. Now, we did this in the first video, so feel free to go back to it, right? What f of 1 is asking us for? This is telling us to find the output when the input is 1. That's what this means here. So in case you're unsure about that, as I said, the first video, we did that a little bit more in detail. So remember, this is your instruction. This tells us how to get the output, and this tells us the input. The f is just the name of it, right? So don't think that that this is f multiplied by x. No, right? This is the name of the function, right? Or the name of the instruction. This tells us the input, and this tells us what to do with the input, right? So that's what f of 1 means. So I shall shift this up to the top here to give us a little bit more space. Right, so let's look at part E. Right, so solution, part E. Now f of 1, we did some of these before. F of 1 just means wherever it have x, you replace it with 1. So this becomes 1 squared minus 3. Now, remember what I taught you before, is that when you are substituting a letter, a number for a variable, an actual value for a variable, put what you are substituted in brackets. Is okay that is positive. We know that 1 squared is 1, but you have to be very careful. So 1 squared is 1, and 1 minus 3 is negative 2. All right, part B is f of negative 3. So again, this is telling us, look at the function f, which is this, and wherever it have x, replace it with negative 3. This becomes negative 3 squared, take away 3. Negative 3 squared is positive 9. Take away 3, which will give us 6. So going back to this part E, what this tells us here is that when the input is 1, the output is negative 2. In this one, when the input is negative 3, the output is 6. Right? That's what the functions, well, that's what the relations tell you. All right, let's go again. Let's go with C. F of 20, and the numbers could go higher and higher, lower and lower, right? So f of 20, this gives us 20, sorry, yeah. You look at your original, right, which is x squared minus 3, so it becomes 20 squared minus 3, which is 400 minus 3, which will give us 397. Now, part D. Right, so part D gets a little bit trickier. But what they are asking you for, just like in this one here, this is telling you to find the output when the input is P. Over here, the input is X. So just like we did in all of these, all we have to do is, wherever it have X, you replace it with P. So this becomes P squared minus 3. Now, you can't really simplify that much further, but I just gave you this because you're going to have some questions with some of these little bit harder ones coming up, right? And that's the answer there for that. Let's look at part E now. Part E is f of t minus 7. Now, this is telling us when the input, remember, whatever is in the brackets is what you are changing x to. And I'm going to write that down here, right? Whatever is in the brackets, whatever is in the brackets, right? Whatever is in the brackets, we change x to that, right? So in this case, what is in the brackets is t minus 7. So we replace x with t minus 7. So this becomes t minus 7 squared minus 3. Right now, the question is not just going to tell you with this alone, right? Most likely it'll tell you what to do with it. This is essentially the simplified form of this, so we can leave this here. Right, and now part F. Now, what do we have for part F? Part F is telling us f of x minus 3. Now, this one is a tricky one, right? What is in the brackets is x minus 3. So whatever is in the brackets, we change the original x into that. So in this case here, we are changing x to x minus 3. So this becomes x minus 3 squared minus 3. Right? And this is what we call substituting into a relation. Right? So sometimes relations are going to have questions. And these here, you could, this is how we do the substitutions, right? Let's go again. Let's say, for example, given that h of x is equal to 4 minus 2x, determine a h of negative 2 and b. Let's just do 2 for now. Right, just do it side by side. B is h of 5 minus x. Right, so let's see what's going on here now. Right, so again, whatever is in the brackets, that is what you are replacing x with. So for this one here, what is in the brackets is -2. So you replace x with -2. So this gives us 4 minus 2 into -2. Be very careful with your negatives. 2 by -2 is 4, right? Well, -4. So this becomes minus 4, which is +4. So this gives us 8. So again, when the input is -2, the output is 8. This one here now. So this will give us 5 minus x. So what is in the brackets, this is now your input. So what we say is that x is being changed or mapped onto 5 minus x. So this gives us 4 minus 2 into 5 minus x. Now this is a good time for us to slow down and think carefully about this question. Remember, according to BODMAS or PEDMAS or PEMDAS or however you want to pronounce it, the order of operations, we have to do what is within the brackets first. It don't have anything to do there. The next step is O or E, which is order or powers or exponents. We don't have any powers here. So the next step now is division or multiplication. We have a multiplication here. This is -2 by these things in the brackets. So you have to expand on the brackets first. So it becomes 4. -2 by 5 is -10, so -10. -2 and -x is +2x. Now, please take note of that. A lot of people has come this far and they do very well, but then they make a mistake and they say, well, 2 by 5 is 10, so it'll be -10 minus 2x. Well, that's a problem. All right, so be very careful with that step. 4 minus 10 is -6 plus 2x, and that's the answer there. So when the input is 5 minus x, the output is -6 plus 2x. So this is how we do the evaluating of the functions here. Yeah. So again, as I always say, you could feel free to copy this down as your own notes, right? It is useful to have your own notes around, a secondary set of notes to help you out when you're studying for these exams, right? So this here is when we evaluating functions or relations, how we do that. So now what we want to go on to is talk about the inverse of a function, right? So sometimes, right? So what we were looking at all the time, right? What we were doing all the time, right? So let's just write down the topic that we do. Inverse of a function. So what we were talking about all the time is that we had an input, right? So we had an input here, right? And we took that input and we ran it through a function, right? So we put this into some function, right? And when we put that input into that function, right, the function converted it into an output, right? And that's what we were doing with all the time, right? The function is the instruction and it tells you what's the input x. The function was whatever f of x was, and the output is each one of the y values that you get, right? So this here is essentially the method for which we do functions, right? And relations, but we use a function generally know as a general name. So if to know, suppose we are given an output now, right? And we want to know what the input was, right? This reverse version that we're going to do here, right? If we want to find the input, right? When we are given the output is what we call the inverse of the function f of x. Inverse of f of x. Right? Like you can think about it as reverse as well, but it is more the inverse of f of x. Now, the name of this, right? The name given to this, or the symbol given to the f of x is this, right? F, and you'll have a little -1 above the f, right? Superscript to the f, and then x. Now, how do we read this? This is read as f inverse x, right? F inverse x. So sometimes it's f inverse of x, right? But f inverse x, this is how we read it. So you're not going to say f minus 1x or f to the -1 of x. It is f inverse x. And what we are using it for is to find the input when the output is given. So what this is predicated on doing is that we are essentially switching the domain and the range, right? To do this, our y values become the x values and our x values become the y values, right? So it is a very, very easy process. I will show you through an example what we do. And then I will write down the steps and then I'll do some more with you, right? Because I have some little bit challenging ones that you need to know for the CSEC level, right? So let's say, for example, we asked to find the inverse of. Now, keep in mind what the inverse is for. We will get back to specific type of question. Right now, we just want to learn the mechanics behind it. So find the inverse of, let's go with 1, f of x is equal to 5x minus 3. Very easy question. All right, so solution. So we start off with the function itself. Now remember, this is based on switching the inputs and outputs. So f of x is equal to 5x minus 3. Always start with this step. Now your next step is, and this step is for simplicity, right? Remember our f of x is really our output values, right? So we let f of x be equal to y. This step is really just for simplicity, right? So we replace f of x with y, right? So it's a lot easier to work with now. So y is equal to 5x minus 3, because remember, to get each y value, this is what we do to x anyway, right? Now, what we are doing, we are trying to create a new equation where our inputs and outputs are switched, because we want to find an equation when we are given the output that we can find an input. So what we do is we interchange x and y. Interchange x and y. Now, this step is not solving for x or making x a subject. What this means is wherever you have y, you will change y to x, and wherever you have x, you change it to y, right? So what this becomes is x, right? Because y changes to x is equal to 5y minus 3. And let's write that back. 5y minus 3. And now this is now essentially your output and this is your input. You switch the both of them. So now what we're going to do, we're going to make y the subject, because we want to know how to get the input given an output. So you want to make y the subject here, right? So now we solve for y, or we make y the subject of the formula, right? So how do we do that? We want to get y by itself. So this is 5 multiplied by y, take away 3. So what we can do to both sides, we can add 3 to both sides. So we get x plus 3 is equal to 5y minus 3 plus 3, right? If I have minus 3, when I add 3 to both sides, this and this cancels off, right? And now this is 5 multiplied by y. So what we do is we divide both sides by 5. And this will give us 5y over 5, but these two 5s will cancel, leaving us with just y. So just rewriting it in a little bit more normal order, it gives us y is equal to x plus 3 all over 5. And this is now your inverse function, right? This tells us if we are given some output, what is the input, right? And now what we do is that we replace, right, or we let y be equal to the notation, which is f inverse of x, right? So f inverse of x is equal to x plus 3 all over 5. Now, let's just break this down on and let's figure out what this is here, right? What this tells us is if we are given some output, right? This is the equation to find the input given the output. So f inverse, this here is the name of the output. The name of the output, right? This here is whatever the output is, right? So the name of the input, this is the input here, right? And this tells us, this whole expression here tells us how to get the input. How to get the input. Right. So let's say that if we have the another part of this question, right? Let's just say another part of this question. The other part of this question tells us this is part B, right? Part two, sorry. Find the input when the output is 7. Is 7. Right? So find the input when the output is 7. What they are asking us to do is when the output, which is x, is 7, right? In this case here, right? So a solution, right? In F inverse, they ask you to find F inverse of 7. Always remember that the inverse function is asking you to find the input. So F inverse of 7 is 7 plus 3 over 2. 7 plus 3 over 5, sorry, which is 10 over 5, which will give us 2. So basically, what this is telling us is that when the output is 7, the input is 2. That's what this is telling us here. So always remember that the inverse function represents the set of the inputs. Right? So let's go again. Let's go with number 2. We want to find the inverse of g of x is equal to um, 2x minus 4 over 3. Right? So our solution. And the steps are pretty easy. So let's just go back up to the steps and we write them down, right? So our first step is you let y be equal to f of x. So wherever it have y, wherever it have f of x, you replace it with y, right? The next step now is interchange x and y. It means wherever you have x, you put y, and wherever you have y, you put x. The next step now is make y the subject. And the final step is where you have y, replace it with the name f inverse x, because this y now represents the set of inputs. Right? So let's just write down the steps here before we start so we can see the steps on the side here. Right? Which is how to find the inverse of a function. Right now, your first step really is to write the function, right? But your first step is write the function. Second step, let's jump to the actual first step is you let y be equal to f of x or whatever other name of the function is, right? If it's g of x, then y be equal to g of x, right? The second step is interchange x and y. Now again, what this means is wherever you have y, change it to x. Wherever you have x, you change it to y. If you have two y's in the equation, you change it to two x's. If you have two x's in the equation, you change it to two y's, right? Number 3 now is make y the subject. Make y the subject of the equation, right? That means solve for y or get y by itself. And step 4 now is let y be equal to f inverse of x. If it was g, let it be equal to g inverse of x. If the name of the function is h, let it be h inverse of x. Right? And these are your steps on how to find the inverse of a function. All right, so keep this close to you. All right, and now let's see how we actually using that now. All right, and let's take this here and move it a little bit. Right, good. All right, so our solution. All right, as I say, first step is really rewrite the equation itself. All right, g of x is equal to 2x minus 4 all over 3. Good. The next step now is let y be equal to f of x. In this case, we have g of x, so we let y be equal to g of x. All right, so what this will give us here is y is equal to 2x minus 4 all over Right, the next step now is interchange x and y. Now, the symbol I like to use for this is this. Right, and that's fine. You can feel free to use this symbol if you want. It means interchange x and y. Wherever it have y, you put x. Wherever it have x, you put y. Right, so this becomes x is equal to 2y minus 4 all over 3. The next step now is make y the subject of the formula. Right, so this is 2y minus 4 divided by 3. Right, so make y the subject. Make y the subject. All right, so how we do this? So first step is you multiply both sides by 3. So 3x is equal to, when you multiply this side by 3, this and this cancels. So you will end up with 2y minus 4. Now, how do we make y the subject? This is 2y, take away 4, so you add 4 to both sides. When you add 4 to this side, minus 4 and plus 4 cancels. So it gives you 3x plus 4 is equal to 2y. And then you divide both sides by 2 because you want to get y by itself. So this will give us y is, well, 3x plus 4 all over 2 is equal to y. All right, so just writing it a little bit more normally now. This will give us y is equal to 3x plus 4 all over 2. And our last step now is you let y be equal to f inverse of x. In this case, the original function's name was g. So you let y be equal to g inverse of x, because this now represents the inverse. So therefore, g inverse of x is equal to 3x plus 4 all over 2. And again, what is this new function used for? If you are given an output, right? This essentially, what this tells us here is this. 3 by the output plus 4 all over 2. Don't worry about the numbers x and y, right? That not important. This is what it really means. It tells us if you are given the output, this is how we find the input, right? So g inverse is the input. So the input is equal to 3 by the output plus 4 over 2. That's what this means. So once you see this inverse symbol, the x stands for the output, right? And the whole thing, the result is going to be the input, right? So actually, I can leave that up there for you, right? So you can see what it really means here, right? So I'm gonna do one more again before we end this video. Last one now is, what if we have some function, let's call it h of x is equal to 5x minus 2 over x plus 4. Right now, there's something that I need to introduce to you all here, right? But to find this term, you will learn about in the next video. So think this through properly. If I say 0 divided by 3, this is how many times 3 could go into 0, right? And we know that this answer is 0. But what if I say 4 divided by 0? Right, try that in a calculator and see what the result is going to be. Right, and what you will get is error, some kind of error. Some calculators say error 2, or a calculator say just plain error or syntax error. Right, this can't work out because you cannot divide by 0. The reason is that this is telling you how many times 0 could essentially be subtracted from 4. Right, and the result of that is infinite. You could take away 0 from 4 infinite times and you will still end up with 4. So there is a value of this called the undefined value of x. It tells us what value x cannot be equal to, right? Because, so think about it, actually, I'm going to change this negative, change this plus, right? If x is equal to 4 here, and this denominator is going to become 4 minus 4, which is 0, and it can't divide by 0. So in this case, what we say is that x cannot be equal to 4. And that is what we call the undefined value of x. But we will do some more of that in the next class. Right now, I just want to show you all how to find the inverse of this type of function, which is called a linear rational expression. So as we did from before, we rewrite the equation first. H of x is equal to 5x plus 2 over x minus 4. All right, now our next step, let's just get our steps here now. All right, it's just the second equation, so we could copy the steps and bring it down. Right. Right. Let's we have our steps here again. All right, so our first step is we let y be equal to f of x. In this case, we have h of x. So we let y be equal to h of x. So wherever it have h of x, replace with y. So that gives us y is equal to 5x plus 2 over x minus 4. Our next step now is interchange x and y. Now again, I use the symbol for interchange, right? You could use the word interchange. If there's another symbol to use, feel free to use it. This means interchange x and y. Now, some people think, and over my years of teaching this, what some people they say, well, they only have one y and two x's. We're not switching the places. What we are saying is wherever you have y, change it to x. Right? It don't matter how many y's you have, just change it to x. And wherever you have x, you are changing it to y. So 5y plus 2 all over y minus 4. So that's an interchanging step. And that's a crucial step because it switches your input and output, which is very important. And now your next step is solve for y. Now this is the place where a lot of people, well, not solve for y, make y the subject, sorry. Make y the subject. This is the point where a lot of people um make some mistakes, right? They get lost here. Now, generally, when the variable that you want to solve for or make the subject is in the denominator, a good place to start, or maybe a good place to start, not all the time, but a good place to think about going is cross multiplication. So right now you are dividing by the entirety of y minus 4. So what we do is we multiply both sides by y minus 4. So what this becomes is x into y minus 4 is equal to 5y plus 2. Right now, our next step here is that we need to gather all the y's together. You bring all the like terms to one side of the equation. So x by y is xy, x by minus 4 is minus 4x is equal to 5y plus 2. Now we need to get all the y's on the same side, right? So now this here is plus 5y. So if we take away 5y from both sides, it becomes xy minus 5y, right? And if you minus 5y from this side, this and this cancels. Now I can add 4x to both sides because I don't need this 4x here. So this is take away 4x. So for me to get it to the next side, I have to add it to both sides. So this becomes 2 plus 4x. Yeah. And now I have my y terms together through factorization, which could go back to my quadratics videos. I taught you how to factorize. This is your common terms, right? Y. So I could factor y out. Xy divided by y is x. And 5y divided by y is 5. So now this gives me, you can leave it as 2 plus 4x. That's fine. Or you can write it as 4x plus 2. And now lastly, no. This is y multiplied by x minus 5. To get y by itself, I have to divide both sides by x minus 5. And that's the answer there. Right now, in the next class, I will teach you all how to find the undefined value. But the undefined value here is that x, if x is 5, and the denominator here becomes 0, so our undefined value here is x cannot be equal to 5. Because if x is 5, 5 minus 5 is 0. And it can't divide by 0. So that's why x cannot be equal to 5. And now y is the subject, which was our third step. So our last step now is we let y be equal to h inverse of x. So this gives us h inverse of x is equal to 4x plus 2 over x minus 5. And again, don't look at it as x and y anymore. What does this mean? As we did above here in the last question, this tells us, the inverse tells us to find the input, right? You have to take 4 by the output plus 2 all over the output plus 5. So if you are given the output, this is how to find the input. And that's what h inverse of x tells us, right? So this here is how we find the inverse of a rational expression. You can feel free to pause the video, copy it down at any point, try it out for yourself, right? And as I say in the worksheet that I will post in the comments at some point, you all can try it out yourself and it should have solutions attached to it too, right? So that will be it for this video. And I will complete functions in the next video when we do a few more questions on these here, the rational type. Use the inverse equation to find actual inputs, right? And do some questions specifically based on finding inputs and outputs. And then finally talking about the composite of a function. So all that will be covered in the next video. So hopefully we could keep it down to 3 or 4 videos for this CSEC functions course. So we actually almost finished with functions. We're very close to the end for the CSEC maths. The add maths functions will come down in a later video when I start to do actual AdMats videos. Right, so that is it for this video. And until the next video, stay safe, everybody, and keep practicing.